So we will talk about the list of topics first. I'll just walk you through the list of topics quickly and then I'll come back. So our training mainly consists of 4 main courses and 1 prerequisites course, total 5. Total 5 courses, and each course takes 2 weeks, so it will take total 10 weeks to complete the training. That is the total duration of the training. The class starts from tomorrow 6:30 a.m. 6:30 a.m. IST. And please don't get confused because there is a time change in US for those who are from US. The class timing start tomorrow in Indian time 6:30 a.m. and this is only for 2 weeks. After 2 weeks the timing will change to 7:30 a.m. and for first 2 weeks it would be 1 hour per day. After that it's going to be 1.5 hours per day. And the classes are from Monday to Friday in India. In US it's going to be Sunday to Thursday. So this is how our class timing will look like, and our course consists of 5 main courses, 4 main courses and 1 prerequisites training. Prerequisites training is nothing but it's all about getting you started. These are the topics we are going to learn during the prerequisites training. We are going to talk about Linux. Basically, some those who are new to Linux, we will get started with Linux. We will see some basic commands. It's all about making yourself comfortable about Linux operating system. You are going to learn some basic stuffs. How do you create file, how to create folders, how to copy files from one folder to another, right? These kind of basic operations in Linux we are going to learn. So after we are done with the Linux basics, we will talk about softwares and web applications. We will talk about what is a software and how does a software work, and how does a company develop a software, who are the different teams involved in the process, what do they do, and what is a web application. Web application is nothing but a type of software that can be accessed on a HTTP URL. For example, google.com is a web application, or facebook.com, flipkart.com, amazon.com. All these are web applications. So we are going to learn what is a web application and how it works. Yeah, give me a second. Okay, nice. Cool. And then we will talk about how do you package your application into a Docker container, and how do you run this application in Docker environment. What is Kubernetes, a brief introduction about Kubernetes, and all these things, right? That's what our first 2 weeks is all about. It's just to get you started, right? Especially those who are new to Linux and new to IT or DevOps side. This program, 2 weeks program, would get you started, right? So we will complete the prerequisites first before tomorrow we are going to start with the Linux basics. First, we will create a Linux machine in the cloud, and then we will move on to our advanced topics. That's the plan. So after we are done with the prerequisite training, we will move on to our 4 main courses. And these are our main courses. First one is continuous integration and continuous delivery. Then we have Kubernetes advanced training. Then we have container orchestration in the cloud and configuration management. These are the 4 main courses. Continuous integration and continuous delivery, it's all about how does a company develop a software, how do they build that into a Docker container, and how do they run a Docker infrastructure, and how do they do the testing, right? There are many things that your software code need to undergo. So we will talk about those practices inside a company, right? I will come back to this course list once again after we discussed containerization. So different tools that we cover during this training, it would include Git, GitHub, Docker for developers, Docker development, Jenkins, and Maven, etc. So this is all about building a automated pipeline for your changed code, to verify the changed code, to validate it, and then deploy into a production environment. Then we have Kubernetes advanced training. Kubernetes is nothing but once you put your software, or once you migrated your software into Docker containers, how do you run those Docker containers in a production environment and serve your software to your customers? That's what this training is all about. The main tools include Kubernetes and Docker, and this is a 2 weeks training. All training takes 2 weeks each. And then we have container orchestration in the cloud. This is a cloud-based container orchestration training, actually based on Kubernetes. It is Kubernetes-based training, but in the cloud. So if you have a cloud environment, many things made easier in the cloud, right? You don't have to manage a Kubernetes cluster yourself. It would be your cloud provider who will manage it. So we are going to learn Google Cloud, Azure Cloud, and AWS Cloud, how they have implemented this Kubernetes orchestration. And after, it is a 2 weeks training. After we are done with that, we will move on to configuration management and monitoring. This is purely based on the software configurations, right? Every software will have different configurations. How do you manage them inside a company? That's what this training is all about. So there are 4 main courses included in this training. And then we have 2 self-paced training. We are not covering them, but you would get access to the videos and a self-paced course. We cover both shell scripting, Python programming, and Chef. Chef is a config management tool like Ansible. We are covering Ansible. Nagios and Ansible is what we cover under configuration management. I also have a self-paced course for Chef, which I would be sharing with you, and also AWS. I have a topic for AWS that would also be shared with you. It would be self-paced training, not instructor-led training, but you can go through it, and if you have any doubts or questions, you can bring it up during the class. That's fine. So this is how our training will look like, and the topic list will look like. So first I will talk about what is containerization and what is Docker, and then we will come back here. All right. I know, I mean, most of you are from different background. So let us talk about what is containerization. Right? So you just think about a software company who has different software components. Think about a cab application such as Ola or Uber, right? They will have different software components, right? They will have one software component for the front end, the mobile front end. When you try to book a cab from your mobile phone, it would be the front end application which would serve your mobile. I mean, you will see different the GUI on your mobile that allow you to book a cab, right? That GUI is available in this particular application. So this is developed by the developers of the respective cab company. It would contain many HTML pages and CSS and everything. Then there might be a backend which would accept the calls coming from the mobile device. Then there can be one software application that is all about finding the location of the one who is booking the cab. location tracker. Then the cab tracker, right? Another application that you use for tracking a cab, tracking a vehicle. And then another application for making the payment using Paytm, right? Any customer choose to make payment using Paytm, then this software component contains all necessary code or all necessary functions that can take care of the Paytm transactions. Then there is some other things that is all about the booking management. Whenever the booking get confirmed, it is this particular component which will take care of the booking. So like that, there can be a lots of software component, some component for analyzing the customer and customer details, another component for understanding the driver and the market, right? There can be some database component. There can be a lots of software component that your company would have developed, and all this software component work together in order to serve your customers. For example, somebody from their mobile phone, when they try to book a cab, the mobile phone will connect to the front end and get the HTML pages and everything, right? And the style sheets and everything, and same thing get displayed on your mobile. And then you try to book a cab. Then what happens is a call will be made to this backend application, and it will then connect to this particular application that takes care of the cab booking, and then which will in fact connect to this particular application to understand the location of the passenger, and connect to a different application to understand who are the drivers nearby. And based on this information, this will decide which driver should reach to the customer, and then a final confirmation would be sent to customer mobile phone. Your cab booking have been confirmed. And then this particular component would start monitoring your driver application, your driver, right? Your driver from their mobile phone, automatic signals would be sent to this particular application, which will track the location of the driver. So something like that, right? There can be lots of applications developed by your development team, and all these applications work together in order to serve your software to your customers. So I'm talking about a cab company who has a software application, something like Uber or Ola. I mean, I'm just saying you, giving you an example. This is how internally it will look like within a company. There can be lots of software component, and all the software component contain lots of functions too. So how do you run a software? All the softwares are developed by your developers, and this software should be running. These programs are getting executed when your customers do something on their mobile phone. So in order to execute these program must be residing inside a machine, right? Of course, a software get executed inside a machine. First of all, you need a machine where you want to run the software. So assume there's a software called Paytm. It contains necessary functions which which allow you to book a cab using Paytm payment method. And assume this code is written in Java programming language. There can be a lots of program within one software. All right, there can be lots of program. Maybe one program that will accept the payment request coming from the customer. Then another program which will connect to the actual payment gateway and try to establish a connection to the payment and then make the payment. A different program, what it does is it will, after completing the payment, it will get the details from the from Paytm, get a response from the Paytm about the payment, and update your database with all the data. So there can be a multiple programs within every software application. There can be a huge number of programs, and every program generally depends on some external module or external programs. Every time developer write a code, they might be using some external program which is readily available. There can be lots of external programs and functions within that program, which developers would make call from their program. So you want this external program to be downloaded too if you want to run these programs, and all this external program can depend on other programs. This is called transitive dependencies. So there can be a lots of dependency that you need in order to execute any of these programs. So together, if you want to run this particular software inside a machine, first of all, the machine must have Java installed in it. All this program need to be copied into this machine. All this dependency need to be downloaded into this machine, and there can be a lots of configuration that you want to mention inside this machine. I mean, you want to tell the software component that to write data to the database, this is the IP address of the database machine. Send the data to this particular machine. So there can be other configuration that you want to give it to this application. So what I'm trying to say is running a software is a lot more complex than you thought. Developing the program is one thing, which is the responsibility of a developer, and running the program inside a machine, running the software inside the machines and inside your different machines, it is the responsibility of the operations team, and they have to have all this headache resolving all the dependencies, downloading all of them, then running the source code, or you may want to compile the source code and convert them into a machine understandable form. Then you might want to build some executable file, and you want to run this executable file in this machine, and along with all the configurations that you need, and the machine must have Java installed. So all these things you have to take care. So this is the case of one software. Like this, there can be many software inside a company, right? There can be many software inside a company. This is only for the Paytm application that we have been discussing. Then there can be other application like booking, driver tracking, passenger tracking. There can be 50 or maybe 100 small services that your company have developed. So it become complex, right? If you want to manage all these services or software components, it actually become very complex. And also for a company like Uber or Ola, it might not be one or two machines that run the software. There can be hundreds or thousands of machines, because one machine is not sufficient to run all these 50 software components. It won't work that way. There can be hundreds of thousands of machines which work together in order to serve your customer. Maybe the Paytm payment component itself, it will be running on 10 or 15 machines. Then the driver tracking component may be running on 50 or 100 machines, right? Depends on the traffic that the application is generating. So the management is tough. It's not easy. So think about this. Your company have decided that rather than developing the code, source code, you know what is mean by source code? It is nothing but the code wrote by your development team. Whenever there is a change that your company want to make on the software, the request will come to the developers, and the development team will start making the code modification. And when they make some code modification, then again, right, the dependency might come. You should worry about the dependency, downloading them, then adding the configurations, then setting up the machine to run the software, downloading more dependencies in here, and then deploying the software into this machine and making this machine ready to run your software. So there are many things that you have to do. So in order to resolve all this problem, assume your company have started developing a file let's call it a file, and this file contain the code modification done by your development team. Whatever code modification they do, they will, this file would contain those code modifications. Then the code depends on lots of external programs which we call the dependencies. The dependencies, and then the dependencies of the dependencies, and there can be a lots of configurations, and then there can be lots of other things. Probably if it is a Java application, Java must be installed, so the Java installation is also there inside this particular file. Or in other words, what I'm trying to say is, whatever you want your software component to run, in this particular case assume this is the Paytm software that is being developed, and in order to run the Paytm you need the dependencies, you need the configurations, you need the Java installations, right? And all these things you put together inside a single file, and your company continuously develop this file. Every time developer make a change in the source code, this file get updated with the correct dependencies, the configurations and everything. And in order to run your software, all you have to do is just execute this file and create a Docker container. Then your Paytm application would start running inside this machine, and this machine is ready to serve your customers or whoever, want to use your software. Got it? So this is how it works. So you don't have to worry about creating a machine, installing Java in it. Continuously, every time a code modification happens, check the dependency list and fix the dependencies. Then add the configurations, making sure that configurations are added and software is compiled and copied into this machine. So none of these things you have to do it manually. Automatically, every time the code modification occur, this file get created and this file contains everything. All you have to do when you want to run your software is to run this file and create a container, and your software would start running out. So this is called a Docker container, and this is called a Docker image, and we will talk about that in detail, right? Don't worry about anything technically, and this is something we are going to discuss in detail in the coming classes, right? After you completed the prerequisites, especially those who are new to this, don't worry. Once we completed the prerequisites, you would get a clear idea. Just try to understand the concept today and not anything technical. Right? So that's what containerization is all about. And for a company who converted everything into a container-based system, they have lots of other advantages. They don't have to, of one thing we already discussed, they don't have to worry about the environment, installing the environment, downloading the dependencies, right? None of these things you need to worry about. That is not the only thing. The container creation can occur within a matter of seconds. So it will speed up the process of running your software. Generally, believe me, for a complex software, it takes hours or maybe days in order to complete. Right? There can be 50 or 60 software components within a company, and there can be thousands of machines where the people want to run the software. So it takes time because all this process need to be completed. But if you have Docker, you keep the images ready to run. So all you have to do is, in order to execute your software, you just execute this file. You execute the same file 100 times and 100 instances of software component would start running. You have a Paytm image, the Paytm software application which your development team have developed. You created a Docker image, and Docker image contains everything your Paytm application need. And whenever you want to run your Paytm application, you just run a Docker container from this image. It hardly take few seconds. And assume you are getting huge traffic and you want to make sure that some 50 components or 50 instances of the software should be running, not one, you want to run 50. You can create 50 containers with the same time from the same file. You can create 50 containers within a matter of seconds. And then you want to make sure that all these 50 containers are healthy. No containers should not go down. If they go down, it should be restarted automatically. That you can set up. Or if any container got deleted, automatically create new container. Make sure that there are 50 containers all the time. You don't have to manually do any of these things. You can actually orchestrate them using Kubernetes or some good orchestration tools. There are many added advantages, right? No companies can meet the speed of a company which completely use Docker and Kubernetes in order to for their development and deployments. So it's our training is all about that, right? Our training is all about that. So there are lots of process a code need to undergo, right? After the code got modified, you want to download the dependencies, compile the code, build it into an executable file, run it inside, right? Put that inside a Docker image, create the Docker image that containing everything that software component need. Then you want to store those Docker images for future use, or anyone in your team might want to download the same file and run the software component in their laptops. And then you want to run, right, in the laptops you want to run it once, you want to do some testing in your laptops, in some other machines in the cloud, right? Then finally you want to deploy the production, making it available to your customer, right? So those machines which serve your customers need to be deployed with this new software that your company have developed. So all these things can be automated, right, in an automated pipeline with a easier way. That's what the main advantage of Docker. And let's take a look at different topic list once again, different courses. After the prerequisites, we have four main courses. Continuous integration and continuous delivery, it's all about how you will develop a continuous pipeline. After the code got modified, automatically you take the code, compile it, build it, download dependencies, run some unit testing, generate the report, then find out if there is any problem with the code. If there is a problem, an email would be triggered to the development team. If not, the code is built into some executable code which is ready to run. And then you create a Docker image, it contains the executable code, it contains all the environment where the code can run. And then you check the Docker image by creating a container from it, then run some basic testing, make sure that the Paytm functions are working. If everything is looking good, then if there is an error, you again want to trigger an email to your development team. If not, then you want to mark this image as a stable image. You want to store this image somewhere, so you would do that, right? So it's right, whatever the procedure the code need to undergo after your development team change the code, then the code need to undergo a huge procedure, and whatever procedure the code need to undergo, you want to automate it. And that's what this training is all about: continuous integration and continuous delivery. Kubernetes is all about, as I told you, for a company who already have Docker images for every software application. They want to run this application inside set of machines and then serve this application to your customers. So how do you run it? How do you do that? How do you make sure that uh, if your customers are not interrupted, they are always continuously being served by your machines? How do you manage those machines? How do you run your applications in those machines? If your application goes down, how it will automatically get created, right? How it will maintain 50, right? 50 machines must run the Paytm application. One machine got crashed, then what will happen? Automatically create a new machine, new container, right? All these things, how do you manage it? That's what the Kubernetes training is all about. And then we have Kubernetes orchestration in the cloud. That is also, and all this training take 12, 15 hours, not 12 hours. Make a note. Container orchestration in the cloud, we are going to learn Google Cloud, Azure Cloud, and AWS Cloud. Nowadays, every company have adopted Kubernetes, and then every cloud providers are providing Kubernetes based services, and we are going to learn them. Many companies uses them, right? We are going to learn them in detail, and then we move on to the config management and monitoring. That is all about managing configurations of a software, and mainly it would be Ansible. And then we are also covering monitoring, which is a tool called Nagios, and this is all about how do you manage your software configurations. So these are the four main courses, and these are self-paced training: shell scripting, Python programming, and chef. And this is not a development training, right? You don't need to do any kind of development job. You are not the one who develop the code, but you are the one who automate all this process which I have been talking about. And but sometimes you have to write some small program in order to achieve this kind of automation. So we are covering shell scripting and Python as a self-paced course. You can watch it, you can go through the videos, and you can go through the articles, and then you can come back to me for any questions that you may have. And chef is similar to Ansible. It is a config management tool. And then we have other, what else? We have AWS also covered as a full stretch course. That also I would share with you as a self-paced training. And then what I want all of you to do is, we have a portal, basil.edu.org. So I want all of you to go through this portal and register yourself. Ajay, did you get a chance to see the video, see the screen? Actually, it was shared. Looks like there was a problem at your side. Yeah. Oh, okay. Okay. Please go to this website, basil.edu.org, and register yourself. Click on this button, create a new account, and then provide your full name, email address, username, email ID, and password. Then click on register button. So please register yourself on this portal, basil.edu.org. And this is the portal that we use for in order to track our course, right? You can do it now. So there would be different courses, right, that I have created in here. You would get access to the respective courses. Whatever course that you see in the topic list, it is the same things that you find here. If you open any course, you can find different module and different article that I want you to read. You can just go through all this article as we learn all this training. There would be assignments that you need to complete, probably on a daily basis or on a weekly basis. There would be lots of assignment and work that you need to complete. And like I said, AWS is one training I'm going to share with you. You would get access to the AWS training. Yes, there are many services we are covering: EC2, VPC, Elastic Load Balances, auto scaling, IAM, S3. It's a 15 hours course. CLI tools, Route 53, SES, RDS, CloudFront, CloudWatch, right? And then a sample project. So we would be covering AWS in detail, but as a self-paced training. Whatever we are covering during the training, the instructor-led training, it would be purely based on Kubernetes. We are covering cloud, but Kubernetes cloud, not anything else, right? Every cloud computing provider provide method for orchestrating Docker containers in the cloud, and that's what we are going to focus on. We are going to focus on different cloud services that help you orchestrate Docker containers. Yes, you must have an account created in the cloud. Yes, that's right. We will do that. Tomorrow we will create an account in AWS. First of all, you need a Linux machine. Tomorrow we will start with creating an account in AWS, and create a Linux machine over there because you need a Linux machine for your practice. That would be the first thing tomorrow. Adesh, it's fine actually. We are covering the 2 weeks prerequisites training. So just make sure that you are doing it very well. Prerequisites training is very, very important. We will learn about operating system and Linux. We will learn about software and web applications. We will talk about the dependencies and different components of a software application. We will talk about Docker, how we can run or how we can run your software inside a Docker container, and how do they communicate each other, what is Kubernetes, right? We will have an introduction about all these things during the first 2 weeks. So you don't really need to be from the DevOps side to learn this course. Of course, that's why you are here, right? So it's fine. Once you are done with the prerequisites training, we are covering everything, whatever is required during the prerequisites. And after that only, we will be moving on to our advanced training. That's the plan. So project is something that you would be working on. It is a learning management project. If you need any, I would be providing you the questions and instructions. If you need, you have to do the project yourself. It is all about a learning management system. It contains different services. One service for managing the student, another service for managing the teachers, another service for the payments, etc. So you will be working on a real project. It is a very advanced project actually, a project which is open source and many companies are already using. So you will have to do, the project currently is not completely moved into DevOps. You have to do that. You have to create Docker images and containers of that project. So migrate that project into a pure Docker based project. It takes time. It's a project that actually takes time, but you would continuously get my help if you have any doubts or questions. Okay, and yeah, that's it. Sumit. So
Hi, good
any
morning,
questions?
Basil. Sumit here.
Naresh, Munawar, good morning. Sorry, I couldn't speak to you.
Yeah. So, Basil, when you say that this is a very complex project
Sheshu,
and will,
hi.
hello.
Naresh or Sumit, any questions? Adesh, anyone? Yasha, Munawar, Sheshu, any questions? Praveen, Jay? Yeah, that's pretty much I wanted to discuss from my side for today. And after you registered an account at basil.edu, please talk to your contact person. He is the one who should approve this. The contact person is the one, you are building contact person, right? Whoever contacted you to attend this training, talk to them and get your access approved on this portal. And the recorded videos, everyday class would be recorded and the videos would be shared with you on a Google Drive. So you would get two access. One is the portal access where you can see the course, manage assignment, manage queues, see your grades, right? All this course tracking is done from Edudo. Then you would also get access to a Google Drive where you can find the daily uploaded videos, recorded videos. Cool. Yeah. So any questions? Yeah, Praveen, go ahead.
Hello. Yeah. How can like I'm from basically from the storage team. Like so, how often need to learn any scripting
Okay, cool.
ML
So let us start
and
tomorrow.
all those?
Same time, same link.
Okay,
We will set up your lab environment. Right? You need an AWS account and a Linux machine initially. We will set it up tomorrow.
okay.
The first thing tomorrow. Yeah. Thank you all, and see you tomorrow. Same time, same link. Praveen, you can talk to your contact person. He will help you with my details.
Okay.
Yeah. Thank you, and see you tomorrow. Bye. Thank you.